I'm Will Anderson. This is a brief overview of my project, a comparison of three wind configurations at different heights in ground effect. Ground effect is a combination of aerodynamic effects that makes an aircraft more efficient near the ground. The ground effect vehicle utilizes this effect to be more efficient, and there are three main types: the plan, the tandem wing, and the reverse delta. I wanted to figure out which was most efficient, and I hypothesized that reverse delta would do the best. To test this hypothesis, I built 3D models of each type in Fusion 360, then printed them on a Stratasys 3D printer. After that was done, I tested them in a Jetstream 500 wind tunnel, changing the height above the ground using a custom adjustable bracket. I collected data at various heights, and then once that was done, I actually made a couple of modifications to the procedure and ran a second trial after it turns out the first trial was somewhat inconsistent. So for trial one, the lift data were super inconsistent, no meaningful patterns could be determined. Drag data had a consistent positive slope for all three models, and the slope magnitude was highest for the tandem wing configuration. The lift drag data was calculated from lift and drag data, so it carried over all the inconsistency. Trial 2 also had inconsistent results. Reverse delta was consistently best, but there was no pattern in change that was consistent across all three models, and the margins of error were too high for that pattern to be considered significant. So for trial 1, most likely culprit for the inconsistency was not keeping track of the angle of attack as well as I should have. So that's where the second trial came in. I used a better bracket, but it turns out that bracket could still rotate relative to the wind tunnel. There's no easy way to fix that, so the best solution from here is probably to use computational fluid dynamics software.